Okay, this video here is going to be for section 3.6 in Math 830, graphing quadratic equations from standard form when we have an x squared coefficient that is greater than 1. So we have 4 here. So my example here I have is y is equal to 4x squared minus 12x plus 10. And I want to graph this and get all the important parts of the graph indicated, like the vertex point and axis symmetry and so forth. So what we'll do here is we'll just take a look at it and say to ourselves, well, we have to get rid of the coefficient that's in front of the x squared. So factor out number in front of x squared. And now we're just going to specifically look at the two x, and the x squared coefficients. We don't look at the 10 here. We just look specifically in here, okay? Because we can't really factor out, we don't really need to factor out what's in the 10 there. We want to complete the square. So we take out 4 out of the two x places. So that would be x squared, and if we divide 4 into negative 12, that would be negative 3, and the x would be there. And we leave that in brackets and add the 10 there. So we're specifically looking at only at the x squared and the x coefficients here. And this is squared, of course. Okay. And what we'll want to do here now is we'll want to complete the square within the brackets here, leaving the 4 out here. Now when we complete the square, this is an odd number here rather than an even number. So we have to use fractions. So we complete the square. And by completing the square in this step, we're going to take half of this coefficient. So half of 3, negative 3, is negative 3 over 2. And we're going to square that. So that's going to give us 9 over 4. Okay, so I took half of the coefficient, just like I did before, negative 3 over 2, and I squared it. And that's what we're going to add in. So we'll add that in now, keeping the 4 outside. So we're adding that in the brackets. Okay, so we'll have to subtract a number now out here. But the number that we actually added to the question isn't 9 over 4 just. It's 9 over 4 multiplied by 4. So then we would subtract 9 over 4 multiplied by the coefficient out in front of the brackets, which is 4. So if we do that, this just cancels out. So we're just subtracting 9 outside of the brackets. And then when we reduce this down into our vertex graphing form, we should have what we need. So that would be 4. This would become x minus 3 over 2. We use the same number that we used here to complete the square in there, and if we actually check that, that would be 9 over 4, which would be this term, and if we took the middle term, it'd be negative 3 over 2 plus negative 3 over 2, which is negative 3. And of course this x and x would be x squared, so that works out, and we still have outside the brackets plus 1 here. So this tells us that a is equal to 4. A is positive, and 4, that means that a is telling us that it's going to be a parabola that opens upward, and also because it's greater than 1, it's going to be a narrow parabola. And here we have that inside here, p is actually 3 over 2. Remember, there's in that general form, there's always a minus sign there. And that q is equal to 1. This tells us that the vertex then is 3 over 2 and 1. So then I'm going to graph this graph now, and I'm going to move my field of view up here into where we can see it a little better. So up like that. And I'm going to draw, because it's going to be above the x-axis again, I'm going to draw this so that I have quite a bit of room to work with here. So here we have our x-axis. And then the y-axis. Again, you start by plotting the vertex point and the axis of symmetry. We know the axis of symmetry is x is equal to p. That's the axis of symmetry. I'm just going to put sim there. So let's plot that point. 3/2. Well, 3/2 is 1 1/2. So 1 1/2 is there, and 1 up. So our vertex point is there. So that's my vertex point. I'll draw a dotted line for my axis of symmetry. And again, because it's going upwards, moving upwards, or opening concave up, we know, and we don't have to worry about it, that we don't have to find the x-intercepts here. It's not going down. So we'll find the y-intercept so that we can plot a couple points to get our parabola here. So find the y-intercept. What does that mean? Well, we have to plug in x is equal to 0. Where x is 0, we'll get where the graph is going to cross the y-axis. So we'll do that into here. Y is equal to 4 times 0 minus 3 over 2 all squared plus 1. Okay, so that would be y is equal to 4 times, well, this squared here, because 0 is just out of there, would be 9 over 4 plus 1. Well, 4 times 9 over 4 is 9 plus 1, which would equal 10. So our y-axis is 10. At y-intercept on here is 10. So we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 right there. Okay, then we use the axis of symmetry and we move 1 1/2 spaces to this, so half a space at 1. So the other point will be right there, and you can see it's a narrower than normal parabola because of the 4a value, and we can just draw our parabola opening upwards like this. So there's my parabola, or my quadratic equation. I'm going to label that. Okay, and that's this. And my axis of symmetry is there. And my vertex point is here. And there we go. In our next tutorial, we'll be looking at one more example with this, and we're going to look at ones that have a values that are less than 1.